I'm Nick Bailey, the Online Education Manager here at CWA, and we'll just go through and just a few housekeeping slides before I turn it over to our eagerly awaited panelists over here that are ready to share some amazing new technologies enabling condition-based maintenance for collection systems. We are offering contact hours for today's presentation. So you'll see an attention check code at the top left hand of the screen. It'll be 4 digits. Please do capture that information and maintain that information throughout the duration of the webinar. And on the next slide, you'll see how you're able to process and claim your contact hours for the webinar. You'll just need to go to on.cwea.org, which is the same platform you're in now. Under the Contents tab, you'll be able to type in the 4-digit code after the presentation for today. It'll automatically be reflected in your mycwea.org or mycwa account. The next slide, we're going to have handouts available from today's presentation. Once our panelists have given us an okay to, we'll go ahead and release it just in case they want to make any additions or do any changes to the deck. After the presentation, we'll include the handouts in the Handouts tab. And you can access that on the mycwea.org website under Handouts. The next slide, we're just going to have, I'm not going to read it for you. The only thing that I will say is that if there are any reporters in the room, then all of our speakers are off the record. So at this point, I'm going to turn it over to Jonathan Borden, and he's going to introduce everyone on his team and let you know what today's presentation is about. Thanks again, Jonathan, and thanks again, everyone.
Thank you so much, Nick, and thank you for the opportunity. We're absolutely delighted to be invited to present here. Just by way of introduction, my name is John Borden. I'm the president of RH Borden & Company. It looks like we have a few more people joining, so good to see you guys on the call here. Our company is headquartered out of Salt Lake City, Utah, just south of Salt Lake City, actually in Lehi, Utah. As you can see, those slides or those states that are in blue is where we currently service. We also provide service really nationwide across the whole country. And so we're delighted today to be focusing on our California friends and neighbors and those that we can serve there. A little bit about what we do. We are a data and field services company. And so we're a bit of a hybrid. There is a lot of data coming into our lives. In fact, I'm going to attempt something that we have never done before. I'm going to call an audible, which is a little bit dangerous to do on a webinar. I've been actually having a conversation with ChatGPT. For all those who are new adopters, this is GPT 4.0, which is really an incredible tool that's a tool of our time. And I've been having a conversation with her. I refer to her as her just because it's a female voice. And just before this call, I was asking her what the most important skill was that wastewater operators should develop in the next few years. I'm going to unmute her and I'm going to ask her to repeat what she just told me. I thought it was pretty profound. I better turn the volume up. You've never done this before, so it's a little bit of an audible, but it should be enlightening. Hey, GPT, we were just really having a conversation. I'm now on the webinar. It looks like we've got Erica, James, Sean, several others that have just joined us.
Great to hear. Whenever you're ready to ask the question, I'm here and ready to respond.
Yeah, hey, could you just repeat the response that you gave previously where we were talking about the most important skills to develop for wastewater operators? Just repeat what you were telling me previous to us starting the webinar.
Sure. The number one skill wastewater operators should develop is strong proficiency in data analysis and interpretation. With the rise of smart technologies and IoT devices, being able to understand and use the data generated is crucial for optimizing processes, predicting maintenance needs, and improving overall efficiency in managing wastewater systems.
Hey, thanks. Appreciate your contribution to the webinar today.
You're welcome. I'm glad I could help. Enjoy the rest of your webinar.
So that's a little bit mind-bending to see what's going on right now with GPT language models. And what I thought was pretty profound was what she was saying about the importance of understanding data. That's exactly what we're going to be talking about today. And that's what we're, as a company, trying to help bring into this domain, specifically for collection systems, which historically have not had a whole lot of that emphasis, a little bit, but not, we think that there can be a lot more opportunity in helping to drive that inside of wastewater collection systems. So that's a little bit about me and our company. I'm going to pass it over to Jason and then to Quinn to also give an introduction for themselves.
Amazing. I've never had to follow up ChatGPT before, but I'm sure it will be only the first of many. So Jason Lake here. I'm happy to be an account manager for RH Borden here in Southern California. I've lived here in Southern California in total 20 plus years of my life. I've been in water in various states of industrial, utility, municipal, on the water side, on the wastewater side, on the treatment side, on the distribution side, on the collection side. You know, I've kind of had a great run being able to learn a lot from the folks who are out there in the field. And I'm really excited with the services that we bring today. Before I was in water for the last 14 years, I was on the software, so on the data side. And that's kind of my technical background. So I always felt comfortable in kind of this 1 foot in software in the digital space, 1 foot in the hard sciences and the water treatment, water distribution. So it's a joy for me to kind of bring these solutions, very, very high tech, into a space that's very hungry and adaptable for new technologies. So if I haven't had an opportunity to meet everyone that's joining us from Southern California yet, look forward to seeing you at a CWEA event soon, or of course, happy to come out to your facilities and answer some questions, but we'll get to more of that later. Happy to pass the ball to Quinn.
Thank you, Jason. So my name is Quinn. It's, as you can see, spelled K-W-I-N. My father wanted to name all of his kids after radio stations, which is a terrible idea. So I've been working for Borden now for about 2-3 years now. Most of the time I've been in Colorado, just moving to Northern California. Before this, I was working in the bulk electric system, which is those giant power lines that tie all of the states in the Western United States together. And when I was working in the electric industry, we all knew that the electric sector was the most important public works sector in the country. And it turns out that that's not true. And I think we might talk about that a little bit, about how really all experts are unified in the water and wastewater sector is the most important sector for public health and safety, as well as comfort. I had a nice hot shower today, and that was wonderful. So I'm in Northern California, looking forward to meeting with many of you. Some of you I see on the list I've already talked with, and really excited to bring you up to speed on what's happening with technology in the collection system.
Thank you so much, Quinn. So with that, we'll go ahead and get started. So we have 3 technologies that we're going to share specifically today. That is acoustic assessments, manhole virtualization, and also INI assessment, which is specifically for INI infiltration locating. We're going to have Quinn give the summary for acoustics. Jason's going to talk about manhole virtualization, then I'll come after that and talk about INI. So it's going to be a nice overview of all this. If we get the opportunity in the future, we can do more of a deep dive. I think you'll have a good background of what each of these technologies can offer by the end of this. But please, by all means, we'll be watching the chat. If you have questions along the way, please throw them in there, and we'll do our best to give you a good overview. So with that, Quinn, take it away.
All right, thanks, John. Hey, I love to teach, and the best teaching happens interactively. So we will have, obviously, a question and answer at the end, but as I'm talking, if you got a question, feel free to put it into the chat or unmute and just interrupt me and say, oh, hey, before you go on, and we'll be happy to answer that question for you. So I'm going to be talking about acoustic assessment. This is using a tool called the SLRAT, which I know some of you have had demos of and know a little bit about. We're looking at a picture of the tool here, but what's really important about this is not the tool itself, but it is what we get out of the tool. With this tool, we're allowed to do a thing which we're calling condition-based assessment. John, why don't you go to the next slide and we'll kick this off. So the way the industry works right now, we're usually looking at a calendar and saying, okay, if it's 2024, we're doing this third of the system or this half of the system. And that is time-based maintenance. We're cleaning, we're maintaining based on what the calendar says. We've done that because we haven't really had a good option up until now to do anything else. What I'm going to talk about for the next 10 minutes or so is condition-based cleaning. And this is where we go in and we now have the technology to look at individual system assets and say, what does this particular pipe, this particular manhole need, and then give it to the system. So let's go on to the next slide, John. This is just an overview of the way we've been doing it for 60 years. We pick a neighborhood, and every 18 months, every 3 years, every 5 years, that neighborhood gets visited by the trucks. We camera, we clean, and then we are done with that activity for the year and we go off and do something else. Let's go on to the next slide, John. There are a few problems with this time-based protocol. First of all, we're going to clean every pipe in the system, even though most of the pipes don't need it. We're going to treat every asset exactly the same. We're only going to see that portion of the system that we're looking at this year. If we're on a 3-year rotation, we will only see 33% of the system, which means we're not seeing 2/3 of the system. And that's where the latent risk happens. That's where the backups occur. That's where the spill happens, that when somebody says, why didn't this get cleaned? The answer is, well, it was supposed to get cleaned. It was on the schedule. We had a truck issue. We had a manpower issue. It takes a lot of water to clean pipes. And, if we're using a combo truck, and if we're using that water to actually clean a pipe that's dirty, great. That was a good use of water, but a lot of the times we're just running through the water and we're literally flushing it. And then, of course, with the new combo truck, the heavy equipment, the fleet regulations, we want those combo trucks to last a lot longer than they have traditionally been doing, because under the new fleet regulations, they're going to be crazy expensive and difficult to replace. In addition, if we can run them less, we're going to use less diesel fuel, we'll put out less carbon into the environment. So these are the problems we're going to try and fix with condition-based maintenance. This is how we use the tool, this acoustic assessment tool, to identify which pipes need to be cleaned. So the tool comes in 2 ends. We've got a transmitter, we've got a receiver. One end has a speaker, one end has a microphone. We put them into adjacent manholes. We push the button. The end with the speaker is going to send sounds down the pipe, like when you're getting your hearing tested. And the listening end is going to compare what it heard come through the pipes with what it would have heard if the pipe was clean. And it's going to make that comparison and give us a score on the capacity of that pipe. Now, a couple of important points about this. This test takes about 80 seconds, which means we can do about 20,000 feet a day. We're shooting for 80,000 to 100,000 feet of pipe a week. Those of you who've been on a jetter or on a camera truck know that that's about 10 times more than we're able to assess with those technologies. This is also a much less expensive way to do it. So we're using this tool to go fast and inexpensively to identify which areas of our system need our attention and which ones don't. And we'll look at a picture of what that looks like here in a minute. But this is what I really want you to take away from this. We've got a tool which we can deploy rapidly and inexpensively to do work that we have traditionally had to do slowly and expensively. So let's go on to the next slide here. All right, so this is what the SLRAT will tell us. It will say between this manhole and this manhole, that's pipe scored an 8, which is the most common score across all the country that we've seen. And if a pipe has an 8, that means there's loads of capacity in that pipe. You probably don't need to spend any time working on that pipe. It's open, it's flowing well. And then you go down, we leapfrog through the system, we'll get to another pipe, put the devices on the adjacent manholes, and the device comes back and says, oh, that's a 2. That tells us there's some significant restrictions to flow in that pipe. That pipe has been reduced in capacity through blockages or offset joints or intruding laterals or roots. There's something in that pipe that's causing a problem or potentially causing a problem, and you need to pay attention to it. So that's this new metric called the acoustic score. And you can kind of see there on the scale what it correlates to in the real world. You know, if we're getting a 3 or below, those are pipes that you should be paying attention to. 7 and above, you've probably paid enough attention to those pipes already. And then when we look over here at the pie chart, this is what the average system looks like. 72% of the pipes, they don't need to be cleaned. Not this year, maybe next year, come back, look at them again. But for this year, let's focus on the 11% of the pipes that are a problem. Now, I'm just going to pause and let you think about this, because this is where the value happens for using this particular tool. Think about what your cleaning regimen looks like, and think about what would happen if you were only doing 11% of what you're currently doing. What else could you deploy those resources to do? Could you do some root foaming? Could you do some spot repairs? What else can you do with the resources that you're currently putting towards that, making cleaning efforts in that 72% of your system that is actually already clean? When I share these results with systems, what I hear is, we got to take a summer vacation this year. It's so nice to share this with guys who are at the end of their rope because they're running a crew of 6 on a system that traditionally has a crew of 10. To be able to say, okay, I know where to go, I know what to do, and I know that I don't need to worry about that whole section that I used to have to worry about. It's just a delightful thing. So that's really what I want you to take away from this piece is the data allows you to kind of catch your breath and know that you're not letting anything drop. So let's move on. Yeah, John.
Can I interject? I just want to echo what Quinn's saying right here and highlight this. In our country today, there's a labor shortage. It's defined, everyone knows about it. It is going to get worse in the next 5 to 10 years. 1/3 of the labor force in wastewater operators will be retiring in the next 5 years. Now, that's a sobering thought. What Quinn is showing here is one of the primary ways that we're going to bridge that labor gap. If it hasn't hit you, and it's prevalent across the industry, if it hasn't hit you yet, it's going to. And this is what we've got to do. We've got to implement these technologies that help us bridge into being much more efficient than just using direct labor for a rotational model. So I just wanted to emphasize and echo, Quinn, what you're sharing is this is profound to our national infrastructure. So carry on. Thank you.
Great. And Tyree, this is a great question. Tyree's asking, do we need to build an acoustic score data in order to be able to use it? We're going to go through the visualization of the data. So what we've got here is a tool that will give us data. And then right now, in the next slides, we're going to walk through what that data looks like. So go ahead and roll through this, John. What we have here is this is what a system looks like with every pipe having been acoustically assessed. We see pipes are color-coded green, yellow, red, and black. Green, again, is pipes that they're fine. What we're interested in is those yellows the reds and the blacks. And in this system, we can see 600,000 feet of pipe, and less than 5% of it is in that critical category. What we need to do now is pull those pipes out so that we're just looking at those and say, how many of them are there and where are they? And once we've done that, we put this on the GIS map and we can say, okay, these are the places that I need to go clean or camera or do something with. And what we see when we go over and look at the side here where it's quantifying this problem, instead of having 600,000 feet of pipe on our worry list, we have 32,000 feet of pipe. And it makes me smile. It makes me so happy when I share this piece I was with a city in Colorado that was grossly understaffed. They had had a broken combo truck for 4 months. They asked us to come in and get the data just so they could check a box with their insurance company. They had no intention of actually being able to do anything with this data because they didn't have the resources to do anything. But when I was able to show them this number, and in their case, it was 56,000 feet of pipe that needed to get cleaned, I said, can you clean 2,000 feet when your jetter is working? And they said, yes. And I said, okay, so that's 26 days of cleaning. Can you get 26 days on the schedule this year, even with your reduced crew? And the light bulb went on and they said, yes, we can now manage our system. And it was kind of spine tingling. It was so much fun to see them go from hopeless to we now have a plan. So this is how the data out of the tool gets applied in real life. Let's go on to the next piece, John. In order to run this test, we have to open every manhole. And as long as we have every manhole open, it's a great opportunity to do a visual inspection of the manhole. And again, a lot of you are doing these visual inspections. We got a form. Well, we're going to jet, and while the jetting is going on, we're going to do a manhole inspection. We'll capture that on a form. That's really important to do. It's the basis of our asset management program. What we'll be able to do with this is we'll roll it all into the same data structure. So John, let's go on and look at what the map looks like here. So here again, we're looking at every manhole in a system. In this case, we're looking at the color condition. So this is every manhole in this system, color-coded, just for manholes. Good, fair, poor. Very actionable. We can see most of our manholes, the color is green. But as we roll through here, we'll say, just show me the ones that are red. And then click on it. We can go grab a picture and see why did this one get flagged as having a red collar? Well, because it looks like this. This is a tripping hazard, a bicycle hazard, a hubcap hazard if you're driving your car over it. Now we can go down and we'll say, okay, let's look at the inside of every manhole, the barrel, the structure. Here's every manhole with a poor barrel. And again, we've got the manhole open. Let's take a picture of it and let's add it up to the GIS system. And then just for grins, let's do one more. We'll roll down and we'll look at every manhole and just the shelf and trough or bench and invert. And here we are with every manhole. Just show me ones that have a messy bottom. And again, we'll pull up the photo. And all of this data is in one place. So we've got pipes. So we know what our highest priority pipes are, and we know what our highest priority manholes are, all done rapidly and put into one GIS, which your guys can look at in the field, or which your engineering staff can look at, or as you as supervisors can look at, say, okay, this is where I'm sending my guys. So that is, I want to show you one more slide. Let's go to the next piece and we'll see what this looks like year over year. So we have a system here. And the first year we came in, we could see that about 68% of their pipes were in that green category. They didn't have enough manpower to clean everything. So we said, just clean the worst. They cleaned all the reds, all the blacks, and the worst of the yellows. We come back the next year, we see that middle pie chart, and they do the same thing. Clean the worst, the reds and the blacks and the worst of the yellows. The third year we come back, we've gone from 68% of the system being clean to 84% of the system being clean. And that was without having touched the pipes that are in that green category, just going after the pipes that actually have problems. The other piece that we get out of this data is we can say, well, those 68 pipes, they didn't get better. We cleaned them and we cleaned them. They didn't get better. This is probably our capital improvement universe. Let's put a camera in there and see what's going on with that. So this is the end case for using the acoustic assessment and the condition-based. It improves the entire system overall with minimal use of resources. We're using every resource efficiently. And Tyree, I hope that answered your question. If not, knock it out in the chat or feel free to chime in, open and unmute yourself. And if that answered your question, great.
Oh, thanks, Quinn. Yeah, sort of. I guess I was also I was thinking maybe that we would need like an iterative approach to collecting this acoustic assessment data or acoustic scores in order to be able to make decisions. But I sort of see how after the last few slides what the application is. So yeah, that answers my question. Thanks.
Great. Thanks so much. Any other questions about acoustic assessment? All right. Well, thank you so much.
Great. I
Thanks
saw
so much.
Sean went off mute. Sean, have you got a question? All right. Great. Well, thank you. Thank you so much, Quinn. Appreciate that. One thing that I wanted to also note, if you're looking at this saying, wow, can I really do this? The answer is yes. You're in good company. I think we're at almost 600 million feet of pipe that's been assessed. We've done more than 70 million. Our company's done more than that. And in every case, we can say it improves the system. And we've also talked to regulators of the state. This has been presented to the Water Board. The Water Board is on board for this. We spoke with them individually, and this actually aligns directly with their request to get more technologies of this nature into collection system management. So yes, there are green lanes as far as we can see to go ahead and implement this. So if any of you want to learn more about how to go about that, please reach out to Quinn and we can answer that. So now, I'll pass the ball over to Jason, and Jason will talk about manhole virtualization and manhole digital twins. So take it away.
Thank you, John. And yeah, thanks, Quinn. Thinking back to the previous service, everyone is responsible for cleaning their system. And it's top of mind. It's something that we're always doing because we have to stick to those schedules. With this, sometimes we forget about how important maintaining our manholes are until maybe it's too late. And what we're trying to do is make it easier, create this new tool that makes it much easier for, in combination with the collections operations and maintenance teams and your engineering partners, to really find the best way to keep track of the health of your manholes. And we're really excited to bring this. So John, we'll go to the next slide and we'll talk about kind of the responsibilities of this group. It looks simple when you put it into 4 words, but gosh, I know there's a lot. I talk to people who have really, really large collection systems, have a large number of manholes, and some of which we might not even see once a year, once every 2 years, once every 3 years. So there's a lot out there, and there are a lot of question marks. But it is our responsibility to go through this process and assess them. And in an ideal world, that's some type of data. Maybe it's the good, fair, poor we were just talking about that you're putting in your own GIS, or hopefully just have operators with really good memories who might be able to keep track of that really bad spot of town that might need some help. And really what we're hoping that they're doing is prioritizing, right? So gosh, I wish I could do a CIP project for the whole collection system every year. I mean, that's not what we have the ability to do. But we got to figure out the ones that are worst. And that's the prioritization. Then, okay, great. I do know which one's the worst. I'm going to go through this rehab process. And you got to figure out what is that right rehab process. Then you got to go out and go bids and work with contractors and a lot of other steps. And then, okay, great. They just did some work. How did it go? And then, that manhole does not disappear, even if you've done a great job lining it. The assessment, the prioritization, the cycle never stops. So there's a lot of work, especially with the tools that we have available that we're working with today. So we can go to the next slide. Here's what you're doing, best available tech. You got hopefully a field of operators who are going out and they're taking a look. We got the flashlight up top, making sure that structure, that picture that we just saw of the crack, we want to keep an eye on those. And hopefully that's not a surprise when we send you a picture of that and identify it. Maybe we're getting a little tricky and we're starting to use a camera on a stick. So at least I get a little bit better view of what it's like 20, 30, 40, 50 feet down in these manholes where it's really tough to try and assess it from the top. And then that last step, maybe we're going to go through the process and bring in-house this really expensive manhole assessment technology. And really, that's just more responsibilities because those trucks are big, they're expensive. And who's going to run it? The CCTV team that's already behind on trying to get to all the other pipes that we said we were going to CCTV. It's just tough to do all these things. They're incrementally getting us what we want, which is more data. We want more information. We want to be able to make better decisions. But these tools just aren't getting us there. So let me tell you about what RH Borden has come up with. Let me go to the next slide. Now, just like with the acoustic assessment, we hear that time is one of the biggest constraints. And so the reason that RH Borden comes out with our own field teams to do all your acoustic assessments is because who's going to do that elsewhere? Same thing with our manhole virtualization. So our team comes out and we go through and build these 2 digital files that give you for the first time a true digital twin of every manhole in your collection system. So on the left, you see how easy this is to set up. This is 1 truck, 2 folks, pop it on, and typically, a whole scan will take between 10 to 15 minutes. And what's happening is we're putting 2 pieces of technology down into the manhole with no confined entry, no risk of safety. Everything that we need to do stays above ground. And we're building 2 files. The top one is a point cloud. So this is using a laser LiDAR scanner that's giving you a perfect digital representation of what that manhole is. Millions of individual data points measuring down to the millimeter. The second piece is the bottom one, and we're building a 360-degree video of that entire manhole from top to bottom. Gone are the days of needing to send someone on a harness into the manhole just to look at what it looks like. Sometimes we got to get work done down there, and we're not going to stop that until ChatGPT figures it out. But most of the time, we're spending a lot of time looking, and I want to eliminate that because I think there's too many safety risks, too many issues with doing that. So we'll go to the next slide, and we'll really talk about what is the purpose of what we're doing. By creating a baseline of your manholes, you're giving, compared to what we're doing today, right? At best, you have an operator who's been on staff for a number of years, and they have a really good memory of where the bad places are, and they're trying to track, well, gosh, it didn't look like this 2 years ago. That's the best we're hoping for, and that's really, really tough. This is something that gives both you and the folks over in engineering who really never see these things happen in real time a tool to know what is the status, what is the priority of all of these different manholes. And then what RH Borden does, our secret sauce, is we take that file that says, okay, here is the millimeter by millimeter wall of that, and we do what we call a degradation analysis. And what that's doing is outputting the image to the left. And what we're doing is we're saying, here's where the wall should be, here's where the wall is, and then calculating that for the entire manhole. And what's cool is it gives us a single score. For the first time ever, one score represents all of the corrosion of the entire manhole. And it really, if you're trying to compare it any other way, it's really, really difficult. Now we'll have this digital twin, we'll have this degradation analysis, and we'll have literally an Excel file or our wonderful GIS model that shows you all of the manholes from worst to best. And now we're able to monitor, hey, here's my worst 20. How are things changing over time? And then that last piece, that enabling the virtual manhole entry. I wish we were all together. At this point, I would probably reach over the table and I would put you in one of our VR goggles. If you've been to any of the CWEA events, I hope you've gotten a chance to do it. But there's so many benefits to having this 360-degree video. First, there is, the most core to it is, if I'm going to go through a CIP process, what is the right way to fix this manhole? Is this a patch or is this a full lining? I've heard someone say, we got the crew in, we thought it was going to be a 1 bag of concrete fix, and it was a 10 bag of concrete fix. Well, that presents a lot of challenges when you don't really know how big the problem is. that video gives everyone the same data to reference. And suddenly we're shoulder to shoulder looking at this video, not shoulder to shoulder at the bottom of the manhole, which isn't a very popular thing to do. The other thing that's really helpful is training, right? So we do want our staff to be really good at knowing, what does a bad manhole look like? What does a good manhole look like? Unless you're going through and you're cycling through a bunch of manholes together, that rarely happens. Now I'm going to enable you to have your own digital library of all of your manholes and see them for the first time from top to bottom. And you and your team can identify, here's what a good one looks like, here's what a bad one looks like. You tell us if you ever see one that looks like this again. And then the last thing I love to point out is, we love to put this in the hands of your city council, and for you to show them, here is what a bad manhole looks like. And for the first time, they're there with you. And you know, it's tough to be the people responsible for assets that are literally underground and no one really likes to think about. This is the first time we're raising the importance by visually showing how bad this situation is. And we love hearing stories of people who been going out for budget for a CIP for their manhole rehab program and never got it until they finally put some members of the city council in their manholes, just to make them realize what they're dealing with. There's a lot of good that we're able to give for the folks who are responsible for managing these manhole assets. Let's keep on going, because I want to go into the details of what that analysis looks like. Oh, go ahead, John.
I'm going to pause here. Sandra asked the question, can the manhole be 3/4 full to do virtual modeling? I'll go ahead and take that. Everything, this does not go below the water line. That said, and I may steal a little bit of your thunder, Jason, I apologize. This same technology can be used for wet wells. It can be used for vaults. It can be used for all kinds of structures. So we do a lot of scanning for wet wells where they have to pump down the water, and then we can do the scan while the water's down. So yes, it does need to be above the water line. It goes everything down to the water line. So it needs to be an empty structure, and then we can scan the whole thing. So Jason, I don't know if you want to add anything on that one.
Yeah, other than, gosh, I hope you don't have a lot of manholes that are 3/4 full. Maybe we should be talking about the cleaning side. No, yeah, like John said, you know, this is in the head space. And for, you know, most of the manholes we ever see, the flow is obviously from pipe to pipe, and not up into the structure of the manhole.
Yeah.
So yeah, we can go to.
Did we answer that, Sandra, for you? Okay. Any follow-ups? Just go ahead and put them in the chat. Thanks, Jason. Keith.
Yeah. Me or Quinn will come in. We'll meet in person. We'll go over everything. Yes, thank you. Okay, sweet. So this is what we're talking about when we mean this degradation analysis. On the left, we have a score, and 0 essentially means through the whole manhole, there's very little delta between where the wall should be and where the wall is. Where you see red, that means we're seeing up to 1 inch and beyond of corrosion. And that's really what we're worried about, is this H2S that's slowly eating away at that manhole structure. So when you see red, that's corrosion. That means we're losing that wall. When you see blue, that's bad too. That's the opposite. That means it's coming off the wall. That's right before things totally fall apart. And it's kind of holding on by part of the structure. So hopefully, you know, wherever you are, you're able to see these rotating. This good one, we see a lot of manholes that look like that. It's awesome. This fair, we're seeing a lot of manholes that look like this too. We're seeing some corrosion, we're seeing some buildup. And then finally, in this needs review, this is one of your challenging manholes. This is the ones that we're going to need to be responsible for prioritizing, maybe going through the assessment of what we need to do. The tough part is, remember, okay, what are we doing today? How are we getting this granularity of data today? It's our operations folks, it's the cleaning team, it's the people that are actually going out and lifting the manholes with a flashlight looking. And if you think that we can go around and you can identify which one's a 0.3 and which one's a 0.6, I'm telling you, it'd be really tough. And that's what we're asking our team to do. When engineering comes over and says, hey, we got budget for 15 manholes, where should we do it? It'd be really nice if a laser and a computer and maybe even ChatGPT could tell us This is it. This is your list. It's sortable. Here's your worst 10. And that's finally what we're able to do, is stop making this impossible ask on our operations folks. So we keep on charging. I don't want to take too much time going through but okay. So here's what we can do day one. I can come out next week and I'm going to give you what this looks like. On the left, we have the standard and the line. I'm able to make a quote unquote wall score from day one because I can make an assumption on where that wall is. I can measure where it is and give you that delta across the whole manhole. If it's brick and non-standard, we're going to get through the process of building that first scan, which is incredibly important because these assets, most of these brick ones, they've been there for a long time and we don't really know what it used to look like. But it'd be really nice to be able to compare where is that grout today versus in 10 years. If I'm losing a lot of grout and maybe that brick is starting to hang off, eventually we're going to have to go through these processes of rehabbing all these brick manholes. Well, I want you to be able to determine exactly which ones are the worst ones because we're going to have a limited budget when we're going through this process. And it'd be great to be able to identify which are the worst ones. It starts by building that first scan. And then from there, we're going to compare it to the scans in the past. And speaking of making that comparison of scans one to another, this is something that is really changing how people are prioritizing their CIP. And John, we could go to the next slide. So this is a video that we were able to capture from a manhole. And as you would imagine, this manhole is going to get a bad score. We're not seeing a lot of the original wall. We're seeing a lot of corrosion. H2S has done its difficult job over many, many years. And it's really totally changed the structure of this manhole. Luckily, not the structure, but the wall. It's changed that wall. And you could see sometimes where, like what we were talking about, where the blue, where it's starting to fall off. Other times you could see, well, it's already eaten away. It's eaten right through where that first layer of concrete used to be. I'm hoping that everyone on this call doesn't have tons of manholes that look like this, but you probably have some. And you're probably going through the process of deciding which ones of these do I put on my CIP. And this is what we found really interesting. Going through this process with customers and now doing rescans, we can not only tell you how bad this wall is in one moment in time, we're learning that it's much more important to learn how is that corrosion, how is that H2S affecting that manhole in this real time. And so that's what this next slide will show us. Up top, this is the wall score analysis from that manhole we just saw. And you see, I got red, I got blue, I got all the things that we're looking at that's going to scare us. That's going to say, hey, we got to do something about this. But incredibly, the bottom is the analysis of, let's call it year 0 versus year 2. So over this 1, 2, 3 year timeline, those walls are not changing at all. And what that tells us is that, yeah, it's an ugly manhole, as you would expect anything in this collection system that's been around for 60 years. What's more important is this manhole getting worse right now? Because I'm responsible for things that are getting worse right now. That's the way as I want to prioritize it. And so we'll keep going because I know I'm kind of running out of time. John, I get too excited talking about manholes. Sorry, team. So here's another structure, right? I'll tell you what it looked like. It was bad. It was really bad. The top one, though, is going to tell us that first score. Just like when I'm looking at a manhole with bricks, I don't know where it's supposed to be, but the bottom, that's the most important part to us today. And this is showing you, here's what the manhole wall was, here's where it is. So just over 2 years, this manhole is getting worse, literally in real time. And now you might have previously been worried about that last manhole because it looked ugly and it had bad wall score. Now I know I can actually find the manholes that are getting worse right now. And now I have the most important way to prioritize where I should be putting my CIP budget. We keep going.
I'm going to jump us down to this one. Is that okay?
Yeah, we could get, so let's go right to the GIS because this is really important. You got to be able to assess this data. So on the left, we have the map. Up top, where it's going through is all of the data that we make available to you, all the libraries of data. And then in the middle, these are the filters. So you're going to want to say, I want to go through the wall scores that are identifying the worst ones for you. And so with this utility we worked with, we did 1,000 scans for them. And previously, they would have been trying to think through, where are my worst 1,000 manholes? We've identified the worst 27 for them. Now, that 27, we're going to sit down, we're going to go through the wall analysis, and you're going to have the time to look through that 360-degree video. I always say the wall analysis, that's going to give you the where. That's going to tell you, I used to worry about 1,000. Tell me where I should spend the most time. The 360 video gives you the what. It says, what is the state of my manhole and what do I need to do to make sure that I'm keeping my community safe? And so that's what we want to be able to deliver. So, in an ideal world, in the same way, you're not going to CCTV the whole collection system in 1 year. We make a program. We work together. We're going to know that a lot of your manholes will come back good. Some selection are going to come back bad. And we're going to go back and do a rescan. And we're going to tell you, these are the ones that are getting worse in real time. What we've seen, the payback of this is being able to be selective with your investment. So the next slide, it just makes a really simple comparison of what you're doing today. Maybe we're doing about 15 manholes a year, and we're doing them hopefully with our best operators telling us where to go. It's a tough job for them to do it, but that's what they do. What we've shown is, to the left, is a typical rescan analysis. So most of that graph is green. Some of that graph is yellow. Maybe we're going to do another rescan of it in another 2 to 3 years. And then we're going to look at the ones that are red. That means that's a manhole that things are getting worse in real time. The scan from 2 years ago versus the scan now shows there's degradation happening instantly. And so that's where I'm going to send my money. And that's where I'm going to make sure that I have the best assessment of our structures. So I'm so sorry. I probably went longer than anyone wanted to talk about this. But I do appreciate those who might be interested and it might be helpful for them. Please let Quinn and I come to your offices and we could talk more and answer questions. Because I know a lot of times these are things, well, engineering is going to need to be responsible for this. Someone else. So, these are multi-layer conversations. But what we're able to deliver is really, really important to maintaining the best assets in your manholes.
Excellent.
So I know the next thing I'm really happy to tell you about is John is going to tell you a little bit about our I&I.
Thanks, Jason. I am so excited to work with Jason and Quinn. As you can tell, they're brilliant. I mean, I want to kind of toot their horns for a minute. They understand both the tool set and the strategy. You can see in both of these, what we're doing is we're moving away from the calendar, rotational base, routine base into a much more data-driven, and it's an exciting space to be in. So Quinn, Jason, thank you so much. Also wanted to just do a check on, I know we've got just a few more minutes here and I won't go too far into the next tool and then pass it back to Nick for any questions and answers. This is a lot of information. It's a tremendous amount of information that is coming to us in new technologies. And we're just trying to give an overview to the three. But as Jason mentioned, if you want, please schedule some time. We can come into your office and go into more detail. I'm just going to take a few minutes to talk about I&I. Now, infiltration and inflow, our favorite topic. This is a challenge across the country. Did you know that nearly half of what is treated in treatment plants does not come from houses or from structures? It comes from the ground. We are treating a lot of groundwater, a lot of rainwater, and it's because our systems have holes in it. And that's called inflow and infiltration. And the most challenging part is just knowing where it's coming from. There are a lot of systems across the country under consent decree because of this problem. Some in the state of California, many in the state of California. Actually, I know that Northern California sees this more than Southern California, as Quinn can attest. Everyone's sensitive to it. Everyone wants to fix it. The question is how. There is a new methodology. We're going to summarize it in this program here. There are 5 pieces, and that piece number 2 is paramount to what we have. You can see we call these data harvesters. All these sensors, all these ways of collecting data, I like to call them data harvesters. So, new program. Number 1, knowing how our basins work in our collection systems is fundamental. We know where our cleaning zones are. We know where our trunk lines are. Do we know where our basins are? So when we come and work with a city or a district, the first thing we do is say, let's pull up your shapefile. Let's look at your system, of your collection system, and let's start to outline where the basins are. The reason we do that is because the next step will prioritize those basins in the biggest contributor to the lowest contributor. Second piece of the program, using a sensor. We use a sensor called the eye tracker. Some of you may have heard about it. The biggest difference between that and other sensors of its type is that it works in a network. You can put out 100 of these and they all talk to each other and they talk to the weather. And so they can tell where exactly water is entering into the system. Third thing is weather events. As I mentioned, the sensors talk to the weather, so we're looking at how the rain enters into the system. We have data analytics that pulls all that together and goes into some really nice data visualizations. Again, in the interest of time, we don't have a chance to go through this in detail, but essentially what we're doing is we're laying out sensors that look like, let me get to this, first in what's called a major basin study. So you can see here's a collection system. We've placed a sensor at the outfall of each basin. The outcome of this will be a prioritized view. So you can see in this column showing that the highest amount of infiltration is coming from this basin. And we're doing this with ultrasonic level monitors. It's not quantifying the flow precisely, it is quantifying the delta between different basins. So we're learning which basin is the top contributor and which one is the minor contributor. We would not want to put much resource into this basin 11382 because of its contribution rate. This is what the data output looks like. You can see this is actually what a level monitor looks like when it's in an infiltration state, or it might look like this, but you're seeing that there are peaks and there are rises and declines, and this all overlaps directly with the weather pattern as well. Once we have the major basins prioritized, we go into a target basin where we will put upwards of 100 sensors into there, one every other manhole. And from there, we can see exactly where the sensors are picking up on the infiltration. Yeah, Quinn, do you want to just talk really quickly about East Bay Mud? I see that you're mentioning it there in the chat. So maybe give you 30 seconds to talk about that.
Well, just that you were showing, Tyree is from Oakland, and I thought he might be interested to know that we were in Oakland with some of these sensors. And if anybody would like to know what we found when we were in East Bay Mud working on their I&I problem, I'd be happy to share that with you sometime.
Yeah. Thank you. More of the outputs here. This is what infiltration looks like when you're using a level monitor. You can see following this line down from the top, the blue, not a whole lot of infiltration. The green, infiltration is growing, and then the gold showing the spikes there. So again, leading with data, using data instead of maybe smoke testing, which is not so data centric, or nighttime flow isolation where people are entering in manholes looking for groundwater. Those are less effective. This is highly effective, and a new technology, again, that is specific to using data. When it all comes up at the end of the day, this is what our final output looks like. You can see the weather flowing across a network of sensors. You can see the water lifting up in those sensors and highlighting this middle one as where the I&I is coming from. It's pretty amazing capabilities now. Once again, the key is that we're putting these sensors into a network to talk to each other and then overlaying them with the weather. So that takes us to the bottom of the presentation. A lot of information for you. Thank you so much for joining us today. It's an exciting time to be in wastewater collections. New stuff is coming. We will not be doing collection system maintenance the way we've been doing it in the past. It is rapidly changing and for the better. So we're excited to share it with you. So with that, Nick, I'll pass it back to you for any final wrap-up items.
Yeah, just a few final words here on behalf of CWA. Thank you again to our attendees and to our panelists and those from RH Borden. We really appreciate your time today. The contact hour information has been posted just as a reminder. The attention check code is 7753, and you'll just need to go to on.cwa.org and under the contents tab and put in the attention check code. So to our presenters, to our speakers, on behalf of CWA, thank you again and enjoy the rest of your day.